Good morning, students. This is a free demo class where I will be explaining you a case study question. And the topics covered in this case study are you need to have the knowledge of volume of hemisphere, cylinder, and applications of volume. This is a case study question. Okay, so I will briefly explain this case study to you. What is it about? So the same case study I'm framing it in so that you can understand easily. Imagine you are in class 10th and your school announces an exciting educational trip to Khurja, the ceramic town. You are excited to see beautiful pottery work of Khurja with a variety of tea sets, crockery, and ceramic tile works. When you got there, amidst all beautiful pots, students start pointing out at shapes like, look, there is a sphere, that is a hemisphere, that is a cylinder. They are pointing it out. So look at the figure 1. This is like a hemispherical ball, and this is a cylindrical jar. So what is the first part? The teacher who accompanied them ask them a challenging question. So that is question number first. Let's go on to the A part. I will read the question and then we'll solve it. This question first part is internal radius R of the hemispherical ball which is filled with water is 9 centimeter. So I can write it here that this is 9 centimeter of the internal radius of the hemispherical ball. And in figure 2, radius and height of the cylindrical jar, radius of the cylindrical jar is 1.5 centimeter. So always convert it into a fractional part. That is always easy calculations will be there. And height is also given to be 4 centimeter. Okay, so radius is given of the hemispherical ball and radius and height of the cylindrical jar are given. Now the question is, if the hemispherical ball is to be emptied in cylindrical jars, then how many cylindrical jars are required? So first students, hemispherical ball is completely filled with water, and to understand how much water this bowl can hold, its volume has to be calculated. So first we'll go step by step. Volume of hemisphere we'll find. So what is the volume of hemisphere? I will like a short form so that you can understand this volume of hemisphere. And that is the formula is 2 by 3 pi r cube. And you know that volume of sphere is 4 by 3 pi r cube and volume of hemisphere is half of it, 2 by 3 pi r cube. And radius is given. So we will just write 2 by 3 pi, we'll write as it is. And then r cube means you can write 9 cube. And what is the unit? Centimeter cube, cubic unit. Now, if we want to pour this water from a hemisphere into small cylindrical jars, how many jars can be filled? To find the capacity of the cylindrical jars, its volume has to be calculated. So volume of the cylinder also, I will find what is the volume of the cylinder, that is pi r square h. And here also radius and height is already given. Pi I am writing as it is. I will tell you why. Okay, you can also write the value. It's up to you. But always solve the questions smartly and so that you can save time also. R square is 3 by 2. I've written in the fractional form into h. This way your calculations will be easy. Centimeter cube. So I have not solved further. I will tell you reason why. Why are we calculating both the volumes? You need to find the volume of both and find how many cylindrical jars are filled. How do you find it out? By division. Okay, so let n be the, you can write like, let n be the number of cylindrical jars. Cylindrical jars, this is cylindrical. To be filled. Okay, so what you'll do, you will divide the volumes. Let's come up to the next slide. Here I will write for you, n is, you have to divide both these. So n will be by dividing the volume of hemisphere upon volume of cylindrical jar. So what is the volume of hemisphere? You know that whenever you have fractions in the numerator or in the denominator, so it's better to write like this. What is the volume of hemisphere? That is, already I have written 2 by 3 pi and r cube, means 9 was the radius, 999, divided by, because fractions are there, so it's better you write like this, otherwise students make mistake. You can also write in this way, it's fine, any way you're doing calculations. That is pi, again cylinder, r square into 4. Now cut wherever you can see that fraction will go off, so we can cut this by 3, and here also I can cut 2, 2 will cut, so fractional part is gone. So, and moreover you are dividing, so now you can write if you want. See, 6 into 9 into 9 pi upon 3 into 3, 9 pi. So you can see, you can cut, and pi will cut by pi. That's why I have not written the value of pi. Even if you are writing 22 by 7 or 3.14, that will also cut. Okay. So you are left with 6 into 9, 54. So 54 cylindrical jars are required whenever the water from the hemisphere is poured into the cylindrical jars. So 54 cylindrical jars will be filled. Okay, that is the first part. Now next move on to the second part. What question teacher asked in the second part? So I will read out the question. See, if in the cylindrical jar full of water, conical funnel of same height and same diameter is immersed in it, then how much water will flow out of the cylindrical jar? So let's see. I will repeat the question again. That question is, look at here, this is a cylindrical jar, and the earlier also radius was given. I will just fill up the radius first. They are talking about this cylindrical jar, and its radius was, our fractional form was 3 by 2, right? And its height also was 4 centimeter, and in the conical flask. Now let's read what they're asking. They're asking that cylindrical jar is full of water, and conical funnel, this is a cone, conical funnel of same height, means the height of the conical funnel is also 4 centimeter, because they are saying it in the question, and same radius, so radius is also same as the cylindrical jar. Okay, so this is immersed in cylindrical jar. How much water will flow out? Naturally, when something you are immersed, this is full of water. And when you are immersed, this thing, conical flask is immersed in it, some water will come out, water will flow out. That water flows out, how will you calculate? That water will flow out, that will be equal to the volume of this cone. So we'll find volume of cone, this conical flask, is formula 1 by 3 pi r square h. This is the volume, and its height and radius is being given. Now see, you don't have to divide anything, you have to just find this. You can write the value of pi also. Wherever you are dividing, you know that later on you have to divide as in a part, then I have not written. Okay, r square 3 by 2 into 3 by 2, and height is 4. Okay, so now we can cut, 3 will cut with 3, and these two will cut with this. So what we are left with, you are left with 66 upon 7 centimeter cube, or approximately you can also write in decimal form, but in exam mostly these long questions we have seen that whenever I go for checking, I've seen they write in a fraction form at the end also, or approximately you can write in a decimal form also. Okay, now this is done both the parts. Now if I'm asking you an additional question, if they ask that what is the remaining water in B, in the cylindrical jar, how much water is remaining? Some students confuse. They, instead of how much water flows out when it is immersed, they are finding the remaining water, right? This minus this. No, students. So understand, when this is immersed in the cylindrical jar, the water will flow out. That water flows out will be the volume of the object which is immersed, volume of the cone only. But if you're asking how much remaining water is left in the cylindrical jar, you need to just subtract volume of cylinder minus volume of conical flask. Like this, you can find how much water is remaining in the cylindrical jar. Subtract the volumes. Okay, so I hope I made myself clear to everyone. So students, practice all these questions, and more case studies are there in this course which I made, mastering case study, which is very much important from the examination point of view, board exam, CBSE. So thank you. Have a good day.